So we are going to create a very basic program using Visual Studio and explore some really introductory concepts. They're very important concepts to know for us to kind of move forward and start creating a program. So I've opened Visual Studio. Now, Visual Studio is an IDE, an integrated development environment. You could technically, if you wanted to, create an entire program using Notepad, but you are missing out on a lot of inbuilt functionality, and you're adding complexity to be able to run these things and build it, because you need to access command lines and whatnot. Using a good IDE like Visual Studio, or if you were using Java, you would use Eclipse or something like that. Just comes with a whole host of benefits. So what we're going to do is create a new project, and you will see in the pop-up that on the right hand side there are a huge long list of templates. A template essentially pre-configures your project for a particular purpose. So are you looking to create a website, or are you looking to create a database integration? Are you looking to create a game or a Windows application, or in our instance, just a console app? So I'm looking to create a console app because it's a really simple way of demonstrating some basic concepts. So I'm going to do that, click on next, and give it a name, example app. Click on next. And you'll be asked, what .NET framework do you want to use? Visual Studio will come with one. Use the latest version. You can download updated versions from the Microsoft website as you need. I've got older versions on here for experimental purposes, but I'm going to choose the latest. Click on create, and it will initialize our project. So it will create the necessary files for your project. It will give you some example code. And if I want to, I can right click here and I can explore and actually see what it is it's created physically on the file system. It's created a solution folder. It's created a folder. It's created our code file, literally what we're looking at here. Like I said, I could go and edit this in Notepad if I really wanted to, and a bunch of other stuff as well that we don't need to worry about. We're going to be working purely within Visual Studio for this project. This is our program. Let's have a look at what functionality we've got. So on the right hand side, I'm not going to refer to this too much more, but this is our Solution Explorer, and it tells us how the structure of our program is set up, what files exist in it and other things. It's basically like a file explorer. In fact, you can right click and have a look in File Explorer and see the structure of your thing as it sits on your computer, but I won't do that for now. On the left hand side, we have a code editor window that we can actually just type stuff into. Before we do any of that, what we're going to do is press on the green Start app, and we're going to run this program. And we're going to see what we get. And we get Hello World printed out. It's pretty straightforward. We can then, of course, just copy and paste this line and write something else. Try and keep the same kind of format of what we've got and just change the text. We can run that again. And we get Hello World, goodbye, and thank you. Easy peasy. And then we have this bit of green thing up here. This is formally called a comment, and it's there for you to put informational text. You start with a double slash and you type your informational text. Why would you use a comment? Well, it's for your own use. It's so that in the future there's some information telling you, here's how this program runs, in case you've forgotten. Or for someone else in your team, if you work in a team later on, explaining to them, here's how this program works. For now, I'm going to do a comment, really basic. This is a program explaining some beginner concepts. And that's it. there's our comment. You can put it at the end of a line if you want to. Okay. Now, what I want to do is explore this line here and really understand what it is it's trying to do. So they can probably interpret what it's trying to do. Let's break it down in a bit more detail. So we have, on the start of the line, we have an object. It's a thing that we are trying to access. It's called the console object. It has been pre-programmed by Microsoft in the .NET framework as something that exists. It gives us access to that command line window that popped up. And it's been pre-programmed with some functionality called WriteLine that will then print out some text and a new line character afterwards with whatever you type into it. So when you run this program, and a program will run line by line heading downwards, when it gets to this line, it will say, okay, I want to access the console object and I want to write a new line and I want that line to say goodbye, thank you. And that is actually what it will be doing. So how do I sort of know that this stuff exists? If I started with a completely blank window, how would I know that there's a console object and it does WriteLine and things like that? This was my challenge when I first started. I was given example code, told to follow it, and then I kind of thought, well, I want to go beyond that. How do I know what else this system can do? And that is where, very helpfully, Visual Studio comes with something called IntelliType. So if I start typing this line out instead, you can see it's giving me some suggestions. When I do dot, that tells me that I'm now finished doing that and I want to do the next thing afterwards. And it will tell me what functionality exists within the console object. And so if I scroll down, I get to see all of the pre-programmed functionality that Microsoft have given to the console object. You've got the color, you've got the window size, you've got WriteLine, which is there, you've got readline, you've got other things as well. We can do very simply, we can access the background color. So I'm gonna click on that, and you can see it even gives me a suggestion. So I can double click on that, and if I press tab, it will complete that. Let's just do that. Let's see what happens. Console.background color equals console color.green. Don't worry about how I would have known it's meant to be that. We'll come to that later, but let's run that. And there we go. Hello world, goodbye, thank you. If you remember, the program runs line by line heading downwards. It wasn't until after we'd done these lines that we told it then to do it in green. And that's why then the debug information afterwards is printed in green. So we have accessed an object called console and we've told it I need a background color of green. And we can see what functionality exists because when you press on dot, it tells you what functionality exists. Easy peasy. Now, the next thing to understand is how would I have known that there's a thing called console? You know, if I started off with a blank window, I don't know where to start. And this is where it's important to think of the concept of a library, literally like a book library. A book library has got different sections in it, and within those sections, it's got aisles, and then in the aisles, it's got shelves, and in the shelves, it's got books. And so you're navigating down the library closer and closer to the book you want. You're looking for Stephen King's It, then you would go to the horror section, and then maybe the K aisle, and then navigate up on the shelves to find Stephen King, and you would find It sitting there on the shelves. It's a good book, good film. Same idea exists here. The library instead is called, well, it's actually called a library within Visual Studio. And within that library, instead of sections and aisles and shelves, you have what are called namespaces. And if I hover over the word console, object, you can see it actually says system.console. That's basically telling me it sits within the system library. The system library is something that just comes with Visual Studio and comes with this project. It's been pre-installed. You don't need to worry about other libraries. But if I, just out of curiosity, type system and then say I'm done with that and dot, tell me what's in it, you can see system.console is there. But then so is system.data and system.drawing and system.formats. And if I click on this to filter it by sub namespaces or whatever, system.text and system.timers and maths and numerics, and there's all sorts of stuff that's in here. And it is a case of memorization, unfortunately. You need to memorize, okay, the thing I want to do, where does it sit? But it sits within a library that sits within a particular section and an aisle and a shelf. It sits within a library and a namespace, and then eventually you get to your object, which is actually formally called a class. You can see this, it's a class. And then that object will have different functionalities. But for example, if I go to system.drawing, then you see we get access to things like colors and points and rectangles and shapes and sizes. If I do system.maths, you will see that we get access to mathematical functionality like square roots and trigonometry and powers and pi and stuff like that. If I do system.environment, we get access to the computer itself, such as the CPU usage and the machine name and the OS version and other things like that. This system object that comes with .NET Framework has got millions of bits of functionality within it that you can explore. And what we're going to do is just explore some of the really basic things, and you'll need to kind of research and memorize where else stuff is. But it all starts just by typing it out. Type out system dot and then see what else exists. There are, of course, many other libraries or packages, as they're called, that we can install when we're looking to do website development. Then there are specific web packages that we might want to install. Desktop apps, you install a desktop kind of package and it gives you access to drawing UI windows and frameworks and things like that. So we're not just limited to system. There's lots of other functionality that you will encounter over time. You can download others from the internet as well. Okay, let's have a look at a couple of other really critical concepts along with kind of this. The first is variables, which essentially are a way of getting your program to remember something so that you can recall it at a later point in your program. You might have manipulated its value along the way, and then you need to recall it and output it later on. The second really important concept for us to be able to do variables is something called a type. And that is essentially telling your program what kind of information is going to be stored within this variable. So a good example for this is if I wrote the following code. Console.writeLine, and I'm going to write this. But I'm also going to write it in a slightly different way. Like this. I'm going to get rid of our background color green just so it's more legible as well. And what I want to do is run this program. And if you've ever done programming before, you'll most likely know exactly what's going to happen here. If you've never done programming before, this might catch you by surprise and you would wonder why on earth it would do this. So let's run this program and see what we get. here we go. Hello world, goodbye, thank you. And we get 1, 1, 1, 1 and 22. Now you might have thought, why are both of them not equal to 22? 11 plus 11 is 22. But this is where the different types of information start to come into play. It's very easy for a person to misinterpret what I would have meant by this. If you thought it was 22, then you misinterpreted what I was trying to do. And so we do not want our program to misinterpret what we're trying to do. There are some programming languages that don't enforce you to say what type of information you're looking to do, and they can fall foul of misinterpreting what you're looking to do, leading to weird and spurious bugs later on. C# is one of those languages that forces you to say, okay, what sort of information this actually is. That's formally called a type. And if I hover over this surrounded by the quote marks, you'll see that it is a system.string, a string, which basically means kind of alphabetical or alphanumerical text. It's treated as kind of words. And when you do the plus sign, what you're not saying is, I want to add these together numerically like maths. I'm looking to join them together as text. And so what you're thinking of here, instead of this being 11, this is 1, 1. And so 1, 1 plus 1, 1 is 1, 1, 1, 1. Imagine if the stereotypical prisoner who's locked away in a jail cell for years and he's doing a chalk tally on the wall. 1, 1, 1, 1. And then he slashes it through for 5 and then 1, 1, 1, 1 and puts another one through. That's kind of what this is doing here. Whereas the line underneath it, if I hover over this, you can see the type is a system.int32. Ignore the 32, the int. 32 bits are an integer. An integer is a whole number. So when you're dealing with a number, then the plus sign here is actually adding them together mathematically. And in fact, you can even see that Visual Studio has interpreted it that way. So when I hover over the plus on this line, it sees it as a string left and string right. And when I do it here, it's an integer left and right. So one is adding them mathematically, and the other one is formally called concatenating them, but joining them together. And so we can kind of rewrite this in a slightly different way, actually, which is where we can introduce the concept of variables. So I'm going to delete these lines. And instead, I'm going to create a string. And I'm going to call it 1, 1. And I'm going to say it is equal to 1, 1. And there is, if I put a comment in, when we're initializing a variable, when we're setting a variable on the program, it has to be done in a specific format. So you have to say the type, and then the name, and then you can say equals, and then the value. So if we copy the same idea to do a number, then we use the type called an int. 11 equals 1, 1. And these are just some things you have to learn. You have to learn that there's a thing called a string, there's a thing called an int, and later on we'll get to things called date times. They're all types that you use. And you have to learn that when you're doing a string, it has to be surrounded by quote marks, where everything else doesn't. It's just something you have to learn, unfortunately. It's once you've done it 2 or 3 times, it's pretty straightforward. So what I'm going to do is I'm going to use these 2 variables in my console write line. So I'm going to go, okay, console write line 1, 1 plus 1, 1. And then I'm going to do the same thing on the line below. 11 plus 11. And you see IntelliType does some cool things. It kind of guesses what I'm trying to do. You can press tab to get it to fill out the suggestion in grey. So now our program, going down line by line, you've got these 2 lines, which you know what they do. Then behind the scenes, it's creating a new variable and storing it in memory. You don't need to know where in memory or how it does that. It handles it all for you. And the program references it as 1, 1, and it's got this value. And then another one called 11. And then we're using those in 2 write line commands. These are simple concepts. I'm not trying to create a funky program or anything here. I'm just trying to demonstrate some very simple concepts that are critically important going forwards. So let's run this and we'll see exactly what we get. And we get exactly the same results as we had when it was written out directly. But this time we're using it from memory, taking it from here into here and from here into here. We've learned 3 very critical concepts so far. First is how packages and namespaces and classes and such are structured, where we might have the system namespace, and within there we've got various things like console and its functionality, write, read, background color, math and its functionality, environment, and so on. But then how namespaces might have sub-namespaces. Security has got cryptography and access control under it with its own individual functionalities and so on. But then how we can install new packages to get access to new namespaces and various functionalities, such as adding system.web. whatever for web development, or downloading completely brand new ones such as Unity for game development, or Google APIs for doing development against Google products and toolsets. There are hundreds of thousands of packages that can be downloaded for pretty much everything that you can think of. The second concept that we learned was that we can create a variable like hello world, have it remembered, and then we can push it through a class into a method like console write line and have it print out into our command line window. And the third and final core concept we cover is about types, where we can use types to ensure that our program doesn't misinterpret what we're looking to do, and also to access specific functionality of that type as well. A string does represent basically some alphanumerical text, and you can do things like join it together, but you can also access things like capitalize all of the letters in it, or lowercase all of the letters in it, just through a simple method. Integers, where is a whole number and you can do mathematical functionality against it, standard stuff that you would know. Date times, which are used to represent year, month, day, hour, minute, second, and you can access functionality against it, such as add a day or add a year, or work out the difference in number of days between 2 date times. But then some we didn't cover, such as decimals, which are decimal numbers, booleans, which are true, false values, and then many that we will cover in future videos, types such as lists and dictionaries and data rows and files and colors. And there are, for all the functionalities you could think of, there are types that go along with it. You can build your own types that have their own functionality built in as well. So there are 3 very important concepts that we've covered.